Alright guys, here is the recording for our real-world applications with our trigonometry and all three of the functions we've talked about, sine, cosine, and tangent. The first example problem here, we're going to go through these pretty quickly. We're going to draw pictures for these. We have a ladder that is leaned against a wall. It makes a 72-degree angle with the ground. The base of the ladder is placed 11 feet from the base of the wall. How long is the ladder? So what we need to know here is how long is the ladder. Ladders, 99% of the time, are leaned against something, making it our hypotenuse. So when we start drawing our picture here, our ladder will be leaned, okay, against a wall. And so here's our wall, and our wall is going to make a 90-degree angle with the ground here. Okay, so here, if you want to label it, you can. Here is our ladder. All right. It is going to make a 72-degree angle with the ground. The ladder is. So that means right here, this is going to be your 72 degrees in that angle right there. All right. We're told that the base of the ladder right here, the base of the ladder, meaning the bottom, is 11 feet from the base of the wall over here. Remembering over here again, if you want to label it, this is our wall. So that means this distance right here along the ground is going to be 11 feet. All right? So what we're going to do first, step one in Pythagorean theorem in trigonometry, is locate your reference angle. Reference angle is down here. Okay? Step two is labeling your angle, labeling your sides. Now I always like to do the dashed line so I know where my hypotenuse is, okay, because we don't know whether this is sine, cosine, or tangent yet. All right, we do want to know how long the ladder is, so that's going to be right here. This is where our x will be. So we're given 11 feet over here, and we're given x on these two sides. So we have to decide which two sides these are, opposite, adjacent, or hypotenuse. And with this, both of these sides are technically adjacent, but one is labeled the hypotenuse. That's why I do this dashed line, so I don't accidentally say this side is going to be the adjacent. Across the 90-degree angle over here, we have our hypotenuse. And so that will make this our adjacent side. So when we look at our SOHCAHTOA, okay, remember our SOHCAHTOA, we look and we have our hypotenuse, so we have our H and we have our A. And we look up here and we see which one has the H and the A. We should know here, now we're using cosine. So we're going to do cosine of our reference angle of 72 degrees is equal to, cosine is going to be adjacent over hypotenuse, so we do adjacent 11 over our hypotenuse of x. Now I know in my classes I talked about the switch and divide. You may do that process if you would like to, but I am going to do the multiplying by x on both sides to cancel this. And so then we're left with x times the cosine of 72 is equal to 11. To get rid of this, we divide both sides by the cosine of 72. So then, whenever we plug this into our calculator, x should come out to approximately, and this is where you need to be pausing the video. You need to plug this in. Okay, if you're at home, we should have downloaded a certain different calculator app, free please, so that we can use our trigonometry functions at home. Okay, once we divide 11 by the cosine of 72, we're going to find out that the length of the ladder is approximately 35.6 feet. Okay. We move on to our second problem here. We have a submarine that dives at an angle of 13 degrees to the surface of the water. The submarine travels at a speed of 720 feet per minute. About how deep is the sub after 5 minutes? So we're looking at how deep, so we're looking at the depth. So if I have over here, I'm going to draw over here kind of squiggly for my water. All right, and I'm going to label that as my water. Our submarine's going to be somewhere down here. I don't know how to draw a submarine, so that's my submarine. We want to know how deep is that submarine. Okay, so here's our 90-degree angle. When he starts over here, he's diving down, and this is where he ends up. And he's diving down at this angle of 13 degrees. Okay, because this is where he's going to start. He dives down, and after 5 minutes, we want to know what's going on. How far down is he? So this will be our x. Now, if you notice in this problem, we are being told he travels at a speed of 720 feet per minute. And we're looking at how deep after 5 minutes. So we have to do some multiplication off to the side. 720 feet per minute after 5 minutes. So we need to take our 720 feet a minute, multiply it by how many minutes went by, and we're going to come out to 3,600. Okay? So this 3,600 is how far the sub traveled. So this guy right here will be over right here. All right? So now that we have a picture drawn, we know what we're looking for over here. Step 1, find our reference angle right here. Okay, covered up my 1 and my 3. So then we need to locate what kind of sides we have. Well, I always want to do my dash to my hypotenuse just in case. I look over here, my x is on the opposite side, so I'm going to put an O for opposite. And notice my other side that I'm working with is across a 90-degree angle, giving me my h. So we look up here at the top and we say which one used O and H, and we find out that it's sine. So we know that we're going to be using the sine. So we're going to take the sine of our angle measure, our reference angle 13 degrees, and we will set that equal to, our sine is going to be opposite over hypotenuse. So we take the opposite of x over our hypotenuse of 3,600. And we need to solve, and as we learned, we multiply by what's in the denominator on both sides. 3,600. Then leave myself room. On both sides, these cancel. So then I have 3,600 times the sine of 13 degrees is equal to nothing but x over here left over. And again, I need you to pause. Go ahead and plug this in exactly as you see it, making sure that that reference angle at 13 is right next to our trigonometry function. Okay, don't mix these two numbers around. The 13 has to go in the parentheses with that sign. So you're pausing, you're going through, we're going to go ahead and figure this out on your own, and then we're going to come back and find out that how deep has the submarine gotten. He's gotten about 109.8 feet down into the water. Okay. Example number 3. We have a ship sailing, he's sailing towards a small island 700 miles away. If the ship is 2 degrees off course, we want to know how many miles it's going to miss this island by. Okay, so I'm going to start off by drawing my little island. I know you guys should learn by now I'm a great artist, okay? My ship is going to be amazing. Here is my ship. Perfect, right? So he's sailing towards this island, all right? This island we see up here is 700 miles away. So that means this is 700 miles, okay? The problem we have here is it's telling us that we are 2 degrees off course, meaning he's going to actually travel up this way, sorry, wrong color, up this way at an angle of 2 degrees, okay? So then when he ends up stopping, we want to know how far off course was he, okay? And this is where our 90-degree angle will be at, okay? So here are our two sides that we're dealing with. So now that we have everything here, we can start off step 1, locate your reference angle right here. Step 2, label the sides that are given, and I always suggest adding in that dashed line so we can see where our hypotenuse is, so we don't accidentally mix up our hypotenuse and adjacent. Now labeling our sides, to see all the way over here, our missing side is going to be our opposite of O. And then the 700 is adjacent, but it's not our hypotenuse, so this is our A. So we have O and we have A. We go back up to SOHCAHTOA, which one has O? Go ahead and fix this. Man, working too late again. All right, Chip say TOA. Some of you guys probably have been questioning that. Which one uses O and A? T for tangent. So we'll come down here and we will make sure that we're going to go ahead and use our tangent of our reference angle, which we found it was 2 degrees, is equal to OA, meaning O over A. So our opposite of X over our adjacent of 700. We should start picking up that pattern now and noticing we need to multiply both sides by the denominator. So we get 700 times the tangent of 2 is equal to, these cancel, giving us X. So pause and go ahead and plug in 700 times the tangent of 2 into your calculator. And then we will find out that the ship is off course by approximately 24.4 miles. Example number 4, last one. A 60-foot ramp rises from the first floor to the second floor of a parking garage. The ramp makes a 15-degree angle with the ground. How high is the second floor? So let's start with this ramp. The ramp right here is going to rise up to the second floor of this building. Okay, so here's our ramp. Here's the ground. The ground in the building will always make a 90-degree angle. It states on here that it's going to go from up to the second floor. The ramp makes a 15-degree angle with the ground. So here's the ground. We have our 15-degree angle. We know that it's a 60-foot ramp. So our ramp is 60 feet. We want to know how high is the second floor. So we're looking at height. So here's the ground floor. First floor will probably be over here, and here's our second floor. So we want to know this right here. So step 1, reference angle. Step 2, get our sides labeled. Okay, here's my opposite, O, and across our 90-degree angle I have H. And in SOHCAHTOA, we see that, again, O and H, we're going to be using sine again. So we're going to have the sine of our reference angle, 15 degrees, is equal to O, which was our X, over our hypotenuse, H, of 60. And as we've seen over and over, multiply both sides by the denominator. So we will get 60 times the sine of 15 is equal to X. Pause, plug it into your calculator on your own, and then see if you get the correct answer. After I trust that you've done this on your own so that you know what you're doing on your test, because we cannot help you with the calculators on your test, we're going to find out that the second floor is approximately 15.5 feet up. Okay, and there are some examples of drawing your pictures and getting your right triangles with your trigonometry real-world applications.